Welcome. This channel is a raw public journal dedicated to software development mastery. Over the next few months, you'll see me focused on rigorous practice, tackling DSA problems, designing complex systems, and solidifying core CS theory. I'm putting this out there for one reason only, accountability. This is how I train myself to articulate solutions clearly by speaking my thought process out loud. This isn't a guide or a course, it's just an unfiltered record of my progress. This is day two, and I'll be doing the second question today. I hope to get more questions done since the one I did yesterday was pretty easy. So, this is question two in the lead code 150, valid anagram, and uh, this is again a lead code easy. Given two strings s and t, we have to return t if t true if t is an anagram of s, and anagram is basically a word that can be formed by rearranging letters of a different word or phrase using all the original letters exactly once. All right, and the constraints are that both the strings contain only lowercase English letters, so that's helpful, and that's helpful because there are only 26 options now, like lowercase English letters, and that's all. So, uh, two things are, uh, you know, since all the letters should appear exactly once again in the rearranged sentence, that means the length of these need to be same. And if the length of the two strings is not same, they can't possibly be anagrams. So like the first check can just be that if s dot size is not equal to t dot size, return false. And let's just have a default true here for now. And what that means is that when I run mm, when I run it with two strings of different lengths, I expect to get false, which is correct. Yeah. Awesome. So now the second case is actually looking at these letters. And when I said it that it's helpful that there are only 26 options, what I mean by that is that I can just have an array of 26 elements. So vector in uh, ARR of length 26, and what I'll do is I'll just have for each letter. So like A can be at index 0, B can be at index 1, C can be at index 2. We like already know the order, and basically we can store the number of times each letter appears in the first string, and then check that the count is similar, is exactly the same for each letter in the second string. So, like for each element, I can say for char C in list S if ARR of C minus A and plus plus. That's all. And what this does is basically, okay, so C minus A, C here, uh, in each loop's iteration, C is just a character in this entire string, and you know, for the first iteration, this character will be A, or the second iteration, the character will be N. And when I subtract this A character from an original character, it basically does like the subtraction converts these characters into their relevant ASCII numbers and then performs the subtraction. So there's like an implicit typecasting, and uh, in this case, for the very first element where the value of this character C is, uh, the letter A, and A minus A is actually zero, and the first element of this array will be incremented from 0 to 1. So that's the general idea that I'm looking at. And once this loops iterate, all the iterations are complete, we'll have a list in this ARR where the relevant letters are populated with the number of times each character appears. And then I can basically run this loop again for the second string, and I can say that, ARR, and this time we'll just subtract these. So every time a letter comes in the new string, we'll expect that, you know, the number was already present and we've reduced it from like the original count. And the expectation is that after the iteration of the second array is complete, all the numbers in this array will be zero. And if at any given point ARR of uh, okay, ARR of C minus A is less than zero, then we just return false. So, if there are more, so for example, if there are three A's here and there are four A's in the second sentence, this ARR C minus A minus minus will make the actual count of A's negative. And that's why if we ever encounter a negative, or if we ever encounter a new character, so in this case, like C was a new character, we'll say that, the number at index one was already zero and we've reduced it, we've done a minus minus. So, if it's negative, then you can just return false saying, this has a new character and this is not an anagram. And basically, let's say after both these iterations, we need to check that all the elements in this array ARR are zeros. And if they're not, then it's not an anagram. So again, we can just say that for in I in ARR, if I is not equal to zero, return false. And finally, we'll return true. If everything worked, if no issues were found, then mm, these were anagrams. And I can just hit run to see that the code works. And it does. And I can probably change it back to the original test case to verify that the true cases are being, yeah, so that's perfect. And I can hit submit, and this works. The time complexity here is O of n, since you know we iterate where n is like the max length of maximum of the length of these two strings, and the time and the space complexity is O of 26, so basically constant. yeah, I think this is the most optimized solution. Thank you.